We are going to have time at the end of the presentation to answer questions, and you'll see the ability, there's a question box where you can enter those questions, and we'll get to as many of those as we can. I'm sure we have a lot of people attending today, and I'm sure we won't be able to get to all the questions, but what we will do is send the questions to the FAQs to hopefully be added to the FAQs on the Khronos and LunarG websites. So during the presentation, if you have questions, please enter them in the question panel. Next, check out the handouts panel. We have some PDFs there for you, PDFs of the slides that will be in this presentation, and also of the Vulkan quick reference. So we're going to turn this over to Neil to get started. We have our presenters today are the Khronos president, Neil Trevett, and also the LunarG CEO, who is Karan Ghavam. Turn this over to you, Neil. Are you with us on the line, Neil?
Yes, thank you everyone for being here. As you've probably noticed, the Vulkan 1.0 launched just a couple of days ago on February the 16th, and this is the first new generation open standard graphics API to launch since OpenCL 25 years ago. So we're happy that you can join us here today for this very significant once-in-a-generation opportunity. So we have just an hour here today, so we don't have time to go into an in-depth programming tutorial, but we hope to give you enough information that you can get the context of what we're trying to do with Vulkan and where the resources are that you can use to start your own journey through the Vulkan ecosystem. So we're going to review the Vulkan goals and design philosophy. We can look at the Vulkan launch resources that are already online. Karan is going to give us an overview of the LunarG SDK, which is the primary tool for developers to use. I'm glad to see we do have a lot of developers here today. That's great. And probably the most interesting part of this, though, is going to be the Q&A. And we're going to try and keep the presentations relatively short so we get time for Q&A. And so please do now enter your questions there in the panel, and we will get to them as fast as we can, answer as many as we can, and post the rest on the website. And we are going to post these slides and the webinar recording as well. So if you're not here, you'll be able to see it later. So let's dive in. So what is the genesis of Vulkan? It was around 2 years ago in the Khronos organization that we found the need for a new generation graphics API was beginning to become much more well-formed. And this was largely due to an unprecedented level of participation from game engine developers who were very actively bringing their requirements and requests for a new generation API. And about 18 months ago, we started a design for Vulkan in earnest. And we got significant proposals, IP contributions, and lots of engineering effort from the working group member companies that you can see here in the set of logos on the screen right now. It really was a high energy, a very positive high energy effort. It's actually more urgency and energy behind Vulkan than any other API that I've seen in Khronos. And I'd like to take this chance to thank everyone in the working group, and particularly Tom Olson, who's on the line and is the working group chair. Now, everyone has put a lot of time and effort into making this come true. So it took us 18 months from really starting in earnest to having the hard launch a couple of days ago, where unlike the other launches that we've done in Khronos history, where a launch means uploading the specification, and then the work has to start to implement and use that API, we've really done our first hard launch, which means we have a lot of implementations and supportive materials along with the specification launching on day 0. And we'll go through some more details, but we have the specification, the reference materials, conformance tests, SDK, and in another first for Khronos, all of that is in open source, and we really want to engage with the developer community on a deeper level than we have been able to before. We also have the compiler front ends and samples both from Khronos members and third parties that we're happy to link to help kickstart the ecosystem. And last but not least, multiple conformant drivers are shipping already on multiple OS, and again, we'll go into more detail. But what was the basic drivers? What's happening in the industry to create this need for a new generation OpenGL? The need comes from a number of different factors. OpenGL was launched almost 25 years ago, and it continues to evolve, and it continues to meet market needs. But there's a need for a complementary API approach to enable a new class of end-user experiences. From the technology point of view, GPUs are becoming increasingly compute and graphics capable. Platforms are becoming more mobile, more memory unified, more multi-core. And from a market requirements point of view, GPUs are going to be not just accelerating graphics on your desktop or mobile phone. They're going to be used in a wide variety of platforms and devices, and used not just for gaming and graphics, but also for compute acceleration, vision acceleration, deep learning, across these diverse platforms. So we need an API that's efficient and flexible and portable across this wide range of different architectures. And again, the games engine developers really gave us a very clear agenda on what we needed to achieve. We needed an API that was explicit. That means we're breaking open the driver black box that we have with OpenGL and enabling developers who wish to get much more direct, low-level GPU control. We want a more streamlined API that gives us a higher performance headroom, less driver overhead, less latency, which is important for things like VR. We want it to be portable across this range of platforms. We don't ever want to have the need for a Vulkan ES, which historically we ended up with OpenGL. We want to design an API framework that from the get-go is going to be portable from everything from a supercomputer to a small embedded system. And then, last but not least, from the hardware developer point of view, we wanted to retain one of the key attributes of OpenGL, and we want to make this an extensible API. So hardware vendors implementing the API can bring new innovations to market at a very rapid rate. And just like OpenGL has been for the last 25 years, we want Vulkan to be a platform for innovation, hopefully for the next 25 years. So how have we achieved that? The basic architecture. So even the screen to update here. The basic architecture for Vulkan has a much thinner driver. So with the traditional OpenGL and OpenGL ES, the driver is quite a large black box abstraction, a high-level abstraction into a state machine that the application developer uses, and there's a lot of functionality within that driver abstraction. A full OpenGL driver can run into literally millions of lines of code. There's a lot of context management, memory allocation, error detection. There's a full GLSL compiler in an OpenGL or OpenGL ES driver, as well as the actual functionality for driving the GPU hardware itself. Vulkan takes a very different approach. Vulkan has a thin driver model, so we put much less into the driver, and we put that functionality into other blocks, primarily the application. So the application now has a lot more responsibility than it did before. It's the application that's doing memory and resource allocation. It's the application that's using multi-threading, however it wants to do it, and it is taking on the work of creating command buffers in parallel using multi-threading and submitting that work down through into the thin driver through multiple queues. So the advantages of having memory allocation and other resource management in the application is that a lot less code is hidden behind the black box abstraction. So the application has total control, and it can decide when memory is allocated. So the application is going to get less hitches and surprises, so a smoother end user experience. Again, particularly important for things like VR. Vulkan, it separates the act of creating work in the command buffers from the act of submitting them through multiple queues, graphics, compute, and DMA queues. This means you can use as many CPU cores and threads as you wish in whatever scheme suits your application to create work. And really, this multi-threading capability was the one thing we couldn't solve in the OpenGL architecture. That was really the last thing that broke the camel's back. Said we can't solve this. We need to go to a new API architecture. And of course, there's a lot of other advantages from having a clean paper design as well. But that was certainly one of the key ones. We actually load stuff out of the driver in a couple other respects as well. We take advantage of Spear. The version of Spear we use is SpearV, as V for Vulkan. This is the Khronos intermediate representation. It will talk a little more detail in a second. But it means that the shaders for Vulkan can now be pre-compiled, and that means we don't need a front-end compiler in the driver anymore, and it gives us a lot more flexibility into what language front ends can be used to drive shaders into the runtime. Out of the box with Vulkan 1.0, we do support GLSL, which is obviously the same shading language as OpenGL for portability. But we expect quite quickly there to be a diverse set of shading languages that people will be able to generate SpearV with. The other thing that Spear does is has a loadable layers architecture. So we don't need error handling in the runtime, which can save performance because we don't have the error checking overhead. So what we can do at development time is to load debug and validation layers, and Karan will talk about how the LunarG SDK takes advantage of that. So we've ended up with a simpler driver with lower overhead, better multi-threading, better latency, and because it's simpler, the different vendors' implementations, I think, will be much more similar than the complex OpenGL model. So hopefully we've also increased portability. So Vulkan is a new generation API, but of course it's not the only new generation API. There are 3 new generation APIs being launched and being used in the industry. One is DirectX 12 from Microsoft, and it's very similar in many ways to Vulkan. It's a similar level of abstraction, but it's only for Windows 10 and only for Microsoft. There's Metal, which is only for Apple systems. The key differentiator of Vulkan is that it's cross-platform. It's an open standard that's not controlled by any one platform vendor. Khronos is an open organization that any company is welcome to join. And already we have Vulkan implementations shipping on multiple versions of Windows, from Windows 7 to Windows 10. Windows XP is actually possible from an engineering point of view. SteamOS has stated they're going to, Valve actually has been one of the main drivers, movers and shakers behind getting Vulkan out of the door. The Linux community are jumping on. Ubuntu and Red Hat are both Khronos members and are adopting Vulkan into their platform. Tizen is the mobile OS from Samsung. And last but not least, of course, Android. I'm sure many of you have saw the announcement that Google have announced that they are going to be adopting Vulkan as a native GPU API in a future version of Android. From a hardware point of view, Vulkan, it's possible to support on any modern GPU, really from OpenGL ES 3.1 4.x GPU on upwards. So how do the different next generation APIs compare to each other? This is a very simplified diagram. If we plot the amount of work you need to port from OpenGL or an OpenGL application to the various new generation APIs. Vulkan and DX12, again, are quite similar levels of abstraction. If you want to get the most out of using the Vulkan API, you will probably have to do a reasonable amount of work to refactor your application to take advantage of the new capabilities that these new generation APIs provide. But the upside of that is that if you do put in that investment, the potential performance uplift can be quite high. Metal is like a halfway step. It is thinner than OpenGL, but it does retain a lot of the traditional OpenGL machinery. For example, the binding model from OpenGL and OpenGL is in Metal, and actually it adopts a lot of the traditional machinery from OpenCL as well. It means that a port from an OpenGL ES app is actually easier to Metal and get a reasonable performance uplift. But if you want to go all the way to the fully explicit APIs like Vulkan, the potential performance uplift is higher. And because we're designing Vulkan as a complementary API to OpenGL and OpenGL rather than as a replacement, that seems to us to be the best approach. Vulkan is a no-holds-barred explicit API for creating these new classes of performance smooth applications. But because Vulkan takes a reasonable amount of investment to use, not every developer will find it the best API, and we're being pretty open and honest and straightforward and trying to provide guidance to the developer community as to when and if you should use Vulkan or should you stick with a traditional API. And I've already seen a lot of good conversations out there on the web. I'm glad that the developer community seems to get this pretty well. So we want to continue to help get this message out there. For many developers, OpenGL and OpenGL will remain the most effective API. Those drivers come with a lot of highly optimized pre-baked functionality in those drivers. If you're moving to Vulkan, you're going to have to take the parts that are relevant to your application and put them into your application code. So this is a very simplified kind of high-level first cut at some of the most obvious use cases, though, where people might find a real compelling advantage to move to Vulkan. In general, if you're really interested to squeeze the maximum performance out of a particular platform that you're on, the explicit low-level nature of Vulkan will typically let you do that. But there are a couple of really interesting cases. If your app is CPU bound, if your GPU is sitting idle because a single-threaded CPU is not able to generate work fast enough, and your app is can be structured so you can create work in parallel, using multiple threads on multiple CPU cores, then you are a prime candidate for using Vulkan, and hopefully you would get significant performance increase if you manage to factor your application in an effective way. Similarly, it's not necessarily all about straight-line performance. If you put a premium on avoiding stuttering and hitching in your application, and that hitching can often come from the driver black box having to do some memory shuffling or memory reallocation at just the wrong time. For example, VR, again, is the classic case where if you stutter in a VR experience, that can be very distracting. And you're willing and able to manage your graphics resources within your own application. Again, Vulkan, I think, can give you the flexibility and the control that you've been looking for. Bottom line, Vulkan is not replacing OpenGL, OpenGL. It's providing an additional choice to developers, so we can create a new class of end-user experiences with more performance, more smoothness, that really wasn't so easy to do with the traditional OpenGL stack. But of course, you don't have to use Vulkan directly. For many developers, the use of middleware will be the way that they get to Vulkan goodness. And going back to where we started this presentation, a lot of the motivation for Vulkan came from the games engine vendors, and the companies that are on the screen now, they've been active in the Vulkan working group to help us design Vulkan. Vulkan, we hope and believe, is their dream API. Now that means, of course, we hope that these games engines will quickly have Vulkan backends, and that means that applications that use those games engines will be able to benefit from the increased performance and smoothness that the games engines provide through using Vulkan without having to change their application. And perhaps that is the way that most people will actually benefit from the new Vulkan API. There's this interesting stack in the middle where if you're not doing a game, or a game engine isn't quite right for your application, perhaps there's other middleware that will begin to emerge out there. We think this is actually a quite interesting area for innovation. We think that there's going to be porting layers, there's going to be layers to take care of the housekeeping code, because there's the housekeeping code is longer because of the explicit nature of the API. But I think very quickly there's going to be a rich diversity of middleware out there to make coding easier, to help you port between different APIs. Many of these middleware engines can be quite domain specific, and we're very keen to motivate and enable this middleware ecosystem to appear quickly. I think with this three-layer, I call it a three-layer ecosystem. It's, I think, a powerful model for an ecosystem. We've seen it work once before in the 3D space, WebGL. And WebGL is a powerful low-level API. Some would argue it's too powerful for a web API, but it's really worked out because having a powerful, fully flexible, low-level API enables a very vibrant and diverse middleware ecosystem. And we're kind of expecting and hoping that the same thing will happen with Vulkan as happened with WebGL. So, what if that's kind of talking about the why of Vulkan? So, what about the what? So, the Vulkan website went live on Tuesday. There's a lot of resources online, and if you've looked at the Khronos website, what we're trying to do with the Vulkan landing page is to be an effective signposting resource. So you can find not just Khronos resources and LunarG resources, but third-party resources out there in the ecosystem. We want to be inclusive. We're linking to third-party websites, and if any of the developers here on the call, if you have samples and tools and sample applications that you would like the community to be aware of, please do feel free to send us links, and we would be delighted to link to you from the Khronos homepage. Of course, we have the IHV websites. You will get your Vulkan drivers as you've always done. Your OpenCL drivers. You'll go to your hardware vendor's driver download page, and Vulkan will be included in the driver download. And then on Khronos, the Khronos website itself, there's broadly two classes of information that we've uploaded. There's what we call the canonical information, that's defining the specification itself, the header files, the feature set definitions. They're coming soon. We want to get developer feedback, and then we'll be setting, defining the feature sets. That's a feature set is a definition of what a platform defines to be necessary to be conformant on its platform. There's all of the reference materials, the quick reference card, which is free for download, reference pages, much more detail, conformance tests, and the test process. And again, for the first time in Khronos' history, all of that is in open source. The specification source is uploaded, the reference card, reference pages, and the conformance tests. And we're looking to enable developers who care to contribute to conformance test evolution. Then there's a lot of other material on Khronos, and its primary purpose is to enable anyone who's interested to build tools and SDKs for Vulkan. So there's source to compiler tool chains, the validation layer, which is the key debug layer, the loader, which is the piece of software that loads up the layers and will redirect commands to the correct driver and GPU in a system. Again, everything is in open source, and we hope that there will be many SDKs built for Vulkan to bring Vulkan onto platforms and OSs that people need. And we're very thrilled that LunarG is the first of those SDKs. Through sponsorship from Valve, LunarG has been working with the working group through the development of Vulkan, and we're thrilled that the SDK is available on day 0, and Karan will talk in more detail about that. But of course, for getting to Vulkan, you need drivers. Again, we're thrilled that a number of the working group members have managed to implement drivers and pass conformance in time for day 0. ARM, Imagination, Intel, Nvidia, Qualcomm, we all have conformance drivers. There are over 30 driver submissions that have successfully passed submissions process. And if you're interested on the gory details, there's a link there. All of the specific products and OSs that are supported are listed in real time on the Nvidia website. AMD have a submission in flight, and we expect many more submissions, of course, over time. I mentioned that Conformance Test Suite is open source. If you are a developer, you find that there's inconsistency between vendors. We encourage you to write a conformance test that will solve that inconsistency. The working group will attempt to bring those tests from the community into a future core version of the Conformance Test Suite, so that inconsistency can be solved at the source. So as we upgrade the versions and upgrade the tests, those tests can be adopted for everyone to run. I want to mention briefly SpearV, because new SpearV specifications launched on Tuesday, as well as the Vulkan spec itself. SpearV is the intermediate representation from Khronos. It's the first cross-platform, multi-vendor intermediate representation that has native support for Khronos type stuff, graphics and parallel computation. There's an excellent white paper from John Kesnick, I'd encourage you to read if you're new to SpearV. So that one of the new specs launched on Tuesday was the Vulkan version of GLSL, which adds the Vulkan features to GLSL, such as descriptor sets and subpass input images and the rest of the machinery that Vulkan defines through the language. I think Spear is in many ways just as fundamental as the Vulkan API. It means that we can pre-compile shaders. We have less runtime compilation overhead. You don't have to ship the source of your shaders and kernels anymore. So we're looking to evolve Spear alongside both Vulkan and OpenCL. There's already quite a lot of activity in the ecosystem, even though we're just a few days in. I've got just a couple of examples here. The Brendel Workshop, they're developing portability layers to have Vulkan and OpenGL running over Metal. It will be interesting to see if that enables Vulkan applications on Apple. And there is actually a game with a beta backend for Vulkan already shipping on Steam. The Talos principal from Crow Team have rapidly implemented a Vulkan backend in their internal game engine, and they are already getting pretty good performance, and the functionality looks good. It's early days, it's beta, so issues to be expected. But it's great that the working group has managed to enable developers to get this far on day 0. So, as I mentioned, we don't have time for an in-depth coding seminar here, but the next face-to-face opportunity is at GDC. There are many deep dive sessions on the program at GDC. The last count was around 12 or 13 sessions. And Khronos has a day that's co-located just a block away from GDC. And those sessions are free. You don't need a GDC badge. The link is there, and more details. We're going to be running a quick fire sequence of in-depth sessions around Vulkan on that Wednesday afternoon. And if you have time and you're in San Francisco, you'd be welcome to join. There's no charge. And those sessions will be recorded and uploaded. And then my final slide before I hand over to Karan is just a kind of a glimpse perhaps into the future. These are not decisions from the working group. These are discussions that the working group is having right now. As I mentioned right at the beginning, OpenGL and OpenGLES are not going away. We're going to actively evolve those to continue to meet market needs. But now we have this interesting mix of technologies and APIs, and we can begin to mix and match them in various ways. For example, Spear, already used by OpenCL and Vulkan, perhaps we can bring Spear ingestion into OpenGL and OpenGLES. So if you're using an alternative front-end language to generate your shaders, why not be able to run them in OpenGL as well as Vulkan? That seems like a kind of an obvious good thing. We actually have a safety-critical working group, and doing safety-critical graphics and soon vision processing. They're actually interested in Vulkan for their next generation, because every line of code in a driver takes a lot of effort and cost to safety certify. Vulkan drivers are small and thin. They're an interesting starting point, potentially. And then last but not least, Vulkan already has OpenGL Compute++. I mean, you have GLSL, so compute shaders are fully supported in Vulkan. You have the additional dispatch flexibility of the multiple queues. But OpenCL still has a level of heterogeneous parallel compute that goes beyond the current Vulkan and OpenGL specs. You know, the C++ shading language, tiered precision, shared virtual memory, dynamic parallelism, where the GPU can send more work to itself. These are all things that have been well tested and proven in OpenCL, and there are discussions ongoing right now as to if and when and how we should best bring that kind of capability over time into Vulkan. So with the Vulkan launch, this is not the end, this is the beginning, and I think we have a lot of opportunity ahead of us to continue to evolve these APIs to meet developer needs. So that's the end of my presentation. So I'd like to hand over to Karan from LunarG, who's going to give a summary about the SDK.
Thank you very much, Neil. And I just want to say this is really a privilege to be here, and it's a very exciting time for Khronos and all the members and everybody who's been contributing to this Vulkan API. So it's been a very exciting week. So hello everybody, my name is Karan, Ghavam, and I'm the CEO for LunarG. We're a software company based in Colorado, and we have been working during the development of this API on developing an SDK so that it would be ready at launch as well. So Vulkan developers will need an SDK. As you heard, Vulkan by design is a low-level API, and that API will provide applications more direct control over the GPU acceleration and multi-threading performance. Since it's a lower level API, a simple program will require more lines of code compared to a simple OpenGL program. So as such, developers will need some utilities and samples to aid in the development process. So this is why there was a lot of motivation to have an SDK ready at the time of the launch. One of Vulkan's objectives is cross-platform compatibility, meaning applications written once can be run on many different platforms. Validation layers and loader behaviors are key in achieving that cross-platform compatibility, and as such, the loader and validation layers are considered canonical, and they're Khronos branded. The LunarG SDK includes these canonical pieces in binary form ready for use. The SDK is supported on Windows operating systems 7, 8, and 10, and on Linux. In regards to Linux, we focused on a few Ubuntu versions for at launch. The key elements for the SDK are utilities, sample programs, and tools to aid in debugging and documentation. The layered design of Vulkan enables a common extensible architecture to install tools layers for code validation, debugging, profiling, and as Neil alluded to, many other creative uses. It will be very interesting over time to see some of these creative uses as they come out. These layers can be enabled during the development to aid in the development process and then removed for the production path to optimize performance of the application. As mentioned before, an objective of the Vulkan specification was cross-platform compatibility. Compatible loader behavior across platforms will be key in achieving that objective. The LunarG SDK includes the Vulkan Loader. The Vulkan Loader is an interface between a Vulkan application, the graphics device resources, and the layer binaries. The loader will do discovery and management of the Vulkan resources and layers that are available to the application and aggregates them to enable access to these resources from within a single application. And also, as mentioned, by design, Vulkan device drivers will assume that the application is using the driver correctly. So most traditional air checks that we have been used to over the last 20 years will not be done by Vulkan device drivers, and hence the validation layers are really essential for application developers during their development process. The validation layers will do checking for correct API usage and will flag any cases of improper usage. They are grouped into multiple libraries within the SDK based on some key functionality groupings that exist currently. To aid in application development, the LunarG SDK will also include some sample programs that are intended to demonstrate correct usage of the Vulkan API. They are written such that much of the code and utilities can be directly leveraged for creation of Vulkan applications. And the samples will also include a searchable web page index to help you find a sample that you need. LunarG will be developing these samples, but as well we are taking samples contributed from third parties as well. VK Trace and VK Replay will be in the SDK as well. These are tools that enable you to capture a trace of the Vulkan API calls made by the application, and then the trace can be replayed at a later time. Usually developers share these trace files with third parties such as hardware vendors to aid in issue isolation without having to provide their application. As mentioned by Neil, SpearV is the intermediate representation to be used by Vulkan. The GLSL validator tool will allow developers to convert their existing GLSL shaders to SpearV. The disassembler will take a SpearV binary, create a textual form that can be edited by users, and then the assembler can turn that textual form back into binary form. And the SpearV remapper is used to make SpearV files more compressible, which can be useful when games or applications have a large number of shaders and need smaller file sizes. RenderDoc is also included in the SDK. During the execution of a Vulkan application, RenderDoc can capture a frame with a defect and allow identification of the API calls responsible for that defect, as well as some fine-grained exploration of the state of the API before and after the calls. So where do you get this SDK? You can download it for free at Lunar Exchange. And Lunar Exchange also offers you the ability to create an account to get asked questions and get assistance if you're having issues with the SDK. However, you can download it for free without creating an account if you desire not to do so. So that covers what is in the SDK. Kathleen, I think you can take it back over.
Thanks, Karen. We'd like to go ahead and open it up to questions, but before we do that, I'd like to launch just one more poll. This is a poll that's going to try to see what sorts of platforms you guys are using for development and check all that apply. Looks like a lot of Windows activity going on there. Okay, so mostly Windows development. So we're going to go ahead and answer your questions. And as I said before, we're going to go through as many of them as we can. And any questions that are left over, we will be submitting to LunarG and Khronos to see if they want to add those to their FAQ pages on their website. The first question is, as a beginner, is it better to learn OpenGL before Vulkan?
I would say probably if you're really new to 3D graphics, probably OpenGL, or one of the traditional APIs, is probably the best place to start learning and not get totally swamped by all the details that you would need to drive Vulkan. The interesting thing to me is over time, as we're talking about the middleware layer, could evolve. So potentially the middleware layer could provide some interesting learning platforms over time. But right now, if I was starting from scratch, I would probably still start with OpenGL.
Great. Is there an official HLSS to SpearV translator planned?
This is Tom Olson. I'm the chairman of the working group. The working group does not have any high-level projects, high-level language projects in, under development, except for ongoing support of the GL slang compiler. We are aware of people in the community, of course, who have pretty large tool chains around HLSL, and we expect those things to show up. It probably won't come through Khronos.
Great, thanks. Next question, will there be a Web Vulkan?
I can take that one. So it's in discussion, but I would, if I was a betting man, I would say probably not. We don't need it. The key of WebGL is to take pervasively available hardware capabilities from the native APIs and to package it up through the web browser so content can be genuinely executed with no source changes everywhere. So this means that with Metal supporting Apple and probably not Vulkan, at least in the foreseeable future, as WebGL evolves, it's going to very carefully need to pick the functionality that could be supported on every platform. I think there is a lot of functionality that falls into that category if you include Vulkan and the other new generation APIs. But the mission of WebGL is to funnel all of that available functionality that's available everywhere and put it into the WebGL API, evolve it with backwards compatibility. That's currently the best estimate on the roadmap for WebGL.
Great. Next question, how do I choose between using Vulkan to do general computing compared to OpenCL?
Well, I can start, but guys, feel free to jump in.
I'm happy to answer, Neil, if you like.
Yeah, go ahead.
I think OpenCL is still more appropriate for like scientific computing kinds of things. It has a lot more focus on type precision requirements and stuff like that than Vulkan has with its foundation being in graphics. So if your application is if you're interacting with graphics, if you're displaying your results, then doing it all in Vulkan is probably easier and more suitable. But if it's a more scientific computing kind of application, then OpenCL is probably more suitable.
Great. And then since conformance tests are going to be open source, what happens if a conformance test appears after Vulkan 1.0 is released and then maybe that changes the compliance? It makes some vendors' drivers non-compliant.
So that's an interesting side effect of the way that we're doing conformance now, which is quite different from the the traditional OpenGL way of doing conformance. We do not have a mechanism for removing conformance certification from a device. And the rule is if you've in good faith designed a device to pass conformance, then you get to call yourself conformant. One of the reasons we're excited about having the conformance test out in public, though, is that as it evolves, community members can run it, and they can, I don't want to say name and shame, but they can name and perhaps register issues. We hope that'll have multiple good effects. One is that it will encourage all implementers to be much more aggressive about updating so that they maintain conformance, and that conformance is visible to the community. And the other, of course, is that the conformance tests can evolve more rapidly and just make the API more reliable. We've viewed it as a problem for quite a long time that developers told us they couldn't rely on common consistent behavior across implementations with OpenGL. We hope that Vulkan, by having open conformance, that will make that better.
Great, thanks, Tom. Here's a question specifically about Nvidia. Are you going to add Vulkan driver support for GeForce 500 series GPUs as well?
We're currently not planning to support Vulkan on Fermi class GPUs, though if that it's not an engineering issue, it's a install base issue. So if that causes you pain, please consult your local Nvidia representative and let them know.
All right, we've got quite a few questions having to do with Vulkan support from Apple, either on OS X and also on iOS. Can anyone talk to that?
So Apple is a member of Khronos, and they actually are on the board, and they're active in several of our APIs, but they have not publicly stated any support for Vulkan at this point. I don't have no inside knowledge. Looking at their Metal launch, they seem to be mainly focused on Metal right now. From Khronos' point of view, there's no barrier to any OS platform adopting Vulkan, and Apple, just like anyone else, will be more than welcome to adopt.
Thanks. Is anyone developing an implementation of OpenGL on top of Vulkan?
There are rumors of projects like that. We don't have any direct knowledge of such. It is certainly feasible. Would have all of the issues that writing an OpenGL driver straight to the metal would have, in that all of that cleverness that has evolved inside the major IHVs over the years, if you wanted to get comparable performance, you could do it because Vulkan is that low level. But you would be signing up for, as I said, duplicating all that cleverness.
Thanks, Tom. Next question. What's the difference between Vulkan and DirectX 12?
I'm happy to take a stab at it. So I think from an external point of view, the biggest difference in what they've become, or in what they actually are, has to do with the platforms that they support and the hardware that they support. I think that DirectX 12 has just a few target hardware devices that it was designed for, and it only has to run on one operating system. Whereas Vulkan supports hardware from tens of companies and supports a much broader set of platforms. And so I think there's a bit higher level abstraction in Vulkan that that accommodates that increased portability. But I don't think that there's cost to that abstraction. I think the abstraction is a good thing and it enables the portability, but you still get the same performance and usability you would from DX12.
Thanks. A question, where should we submit code samples for the SDK?
You have some options there. Karan, why don't you speak about the LunarG SDK?
Yes, yes. Actually, on the resources page that Neil had referred to, there is, under the section where there are samples, a link to the samples GitHub that LunarG is hosting and maintaining for samples. So you can certainly go and submit samples requests there. And then we do have a process of looking at these samples and making sure that they're structured, they're good examples, etc. And then we will pull them into the SDK. Today, I think 100% of all the samples that are in the SDK. Over time, we'll probably be applying judgment about which ones are really the best ones to include in the SDK.
Then if I could go, then add another detail. So if you go to the Khronos, the github.com/Khronos group, there is a sub-project under there called Vulkan-samples. All of the open source repositories in Khronos, we're having a last-minute whip around to figure out exactly what sort of licensing and CLA we're going to put on that. So we aren't currently taking samples there, but that directory will be available as soon as we figure out the terms under which we'll ask you to contribute them. There is one project right. No, actually, I don't think. Sorry, there is one in flight, but it hasn't landed yet. Currently, it's empty, and I would say watch it for the licensing terms to show up.
All right, thanks. Will Vulkan eventually work with newer Nvidia drivers?
Yes, obviously Vulkan will make it into the production Nvidia drivers. We're currently in beta, but we're basically waiting on WebGL certification. Once that's done, Vulkan will be in the mainline Nvidia drivers.
Thanks. Will we be able to mix OpenGL rendering with Vulkan rendering?
So Nvidia at least has, I think we've published the extension that allows such a thing. We have, one of our first extensions is a pretty limited form of interop where you can synchronize between an OpenGL context and a Vulkan queue, and additionally copy image contents from Vulkan to OpenGL. So interop is certainly a technical possibility, and I expect we'll probably have additional extensions in the future.
Great. So there's another question from another asker. Will the use of hardware-specific extensions still be present? So it sounds like the answer is yes to that.
Yes, it will.
Yeah, and that's important because that's the one of the innovation vectors that lets people experiment quickly at their own pace.
Great. Here's someone who's doing development in Unreal Engine projects using, and he wants to know if that can be done with Vulkan. Can I integrate Vulkan inside of a game project with Unreal Engine?
That would be a question for Epic. Epic are a member of the working group. I don't know if they've announced any commercial plans.
What is the desktop GPU's hardware support for the render passes, considering DX12 doesn't have this concept?
Hi, this is Graham from AMD. I'll take a stab at this because I during development I was a bit concerned about whether we'll make use of them on desktop GPUs, but during the implementation of our drivers, I kind of realized that there are a few optimizations that we can make given knowledge of the structure of the frame. So yeah, I mean, it is a feature that was kind of strongly requested by our mobile members, but I think that if you use them wisely, then there are certainly things there that desktop GPUs can take advantage of. So yeah, it's not a mobile only feature. I think there's opportunity there for desktop as well.
Another AMD question: is there an ETA for AMD to pass conformance tests and share proper drivers?
Proper drivers, yeah. It's one of my favorite terms. Yeah, so the driver we posted today, well, we have online today, has actually not passed the conformance test yet. We have a few kinks to iron out. It's literally in our internal drivers. It's literally down to single-digit number of issues out of somewhere in the region of like 40,000 tests in the suite. So the driver we posted is beta. We're preparing our logs and our first non-beta driver with a wiggle test and all that stuff will be conformant, or at least have the logs posted and be awaiting the committee's decision.
Great, thanks, Graham. Will Vulkan have an interoperability with CUDA?
Question for Nvidia.
Yep.
Yeah.
Go ahead, Neil.
You go ahead.
I expect it would happen eventually, but I don't think we have something in the works in the short term.
Okay. Will there be a SpearV layer to allow running DirectX over Vulkan?
Well, so the issue there would be to translate DirectX shader code that is, post-compiled code into SpearV for consumption. That is certainly a technical possibility. The other option, of course, is to compile direct from the HLSL if that's how you're generating your binary blobs, which I think would be typical in the more modern DirectX APIs. Either path will work. Khronos isn't particularly planning to do that work, but if that is the best path for your engine, we hope you've got all the tools, and if not, let us know. By
design, how can Vulkan be used to create a web application?
So as we were talking before, I think if you're creating a web application in 3D, use WebGL. It's native in the browsers. You don't need a plugin, and I don't think there will be a Web Vulkan, but WebGL will, over time, integrate next generation API capabilities as they become pervasively available.
The other possibility that's worth bearing in mind is that we did consider the needs of the WebGL implementation teams as far as using Vulkan as a backend for a WebGL implementation in a browser plugin. It's got the robustness available. That's a required feature of Vulkan 1.0. It is not at all unlikely that we might see WebGL implementations over time migrate toward targeting Vulkan, just as today WebGL on Windows often targets DirectX rather than OpenGL.
Thanks. What is the desktop GPU's hardware support for the render passes, considering, and I think I already asked that, didn't I, that the DX12 doesn't have that concept? I did. Sorry about that.
Yeah.
What is the official GLSL to SpearV compiler, and is it available for download already?
That's the GL slang compiler that was referred to.
Okay.
Sorry, I don't remember exactly where it is in the website, but that is the one that we are all using and are hoping will be the standard, although the community is, of course, welcome to build on that. is an open source project as well.
In a nutshell, how is the Vulkan Loader detected? How does the Vulkan Loader detect vendor drivers in a Linux system?
This is John Ashburn at LunarG. I can take that question. So on Linux, the loader detects the drivers via a JSON file that's installed in some system locations. JSON file indicates where the actual driver library is. There's also, if you're a developer, there's some environment variable overrides that you can use to point to a different location rather than a system location to find the JSON files.
Can OpenGL functions be used when using the Vulkan API?
The short answer is no. It would require, remember all the hidden state that is being carried around by OpenGL implementations. For that to interact with the very explicit exposed state of Vulkan is a pretty gnarly technical problem. Jeff Boltz, who spoke earlier, talked about an Nvidia extension to allow that. My guess is, and Jeff can correct me if I'm wrong, that it would have to be fairly hands-off and you'd be explicitly passing surfaces between one side and the other and otherwise maintaining them as pretty independent entities.
Yeah, so
can I just, oh, sorry, Jeff, I was just going to add to that. I think the question is, could you use GL and Vulkan in the same application? And, without interrupt, you could render to different windows and those kinds of things with GL and Vulkan. But yeah, you would need an interrupt extension to mix rendering. And if that's what you were going to say,
I was going to say pretty much that. So in our implementation, we actually packaged the OpenGL and Vulkan drivers in the same DLL, and so there's really you can certainly use both of them in the same process, and that would be true even if they weren't in the same DLL. But yeah, you can use them independently. It's sharing data or sharing state between them requires an extension to one or both APIs.
True, though, for multi-window applications, there's no real problem. You just can't share, as you said.
So we were talking about SpearV before. Does anyone remember what the question was?
Do you want me to?
Yeah, that'd be great.
I can answer that now.
Thanks.
So under the GitHub Khronos group folder, there is a GL slang repository, and that's been there for a while as the official reference Khronos validation layer, to validate that the GLSL you're using conforms to the specification. And that has on it an example translator from GLSL to SpearV. And right now it's probably about 90% complete. It's an open source project, and it is implementing the new version of GLSL that supports the Vulkan features that were mentioned earlier. The push constants and descriptor sets and input passes, a few things like that are new to Vulkan, and there's some features that are not in Vulkan that GLSL won't support when you're compiling for Vulkan. So that tool is available. You can translate your modified for Vulkan GLSL into SpearV, and then send that into the drivers for the different platforms. And you're welcome to contribute to that project as well.
What can we say about Vulkan performance with ray tracing?
Well, the fundamental pipeline model underlying Vulkan is, essentially exactly the OpenGL model. So anything you do through the rasterization side is, you're doing traditional rasterization. You certainly can use the compute shader capability to write a ray tracer, just as you could have done with compute shaders in GL. Maybe you have a little more flexibility, but there's no explicit support.
Will Vulkan extensions that get used a lot eventually get added into the core of Vulkan?
I would say yes. That is the path we expect. Is that we'll prototype new hardware functionality as extensions and absorb it over time.
And someone's asking about the Raspberry Pi having Vulkan support, or the next Pi. Have they had any involvement with Khronos and with this project?
Broadcom is a member and an active participant in the working group. The Raspberry Pi Foundation itself is not. Our old friend Espen, who is the godfather of Raspberry Pi, was a member of the working group back in the day, but we haven't heard from him for a while except in bars and places like that. Any other comment from other people?
I don't have any specific knowledge, but I do expect Vulkan to appear in quite small embedded systems in general, so it's not, certainly possible.
Are shaders written in Vulkan in the same way that they're written in OpenGL?
You have the choice to do that. In OpenGL, the only choice you had was to use GLSL and pass the GLSL into the driver. In Vulkan, you can also write in GLSL and use an offline tool chain to translate that to SpearV, and then the standard Vulkan only accepts the SpearV. But there's plenty of other choices, right? There'll likely be lots of people experimenting with different languages and different kinds of tool chains, middleware and game engines and all of that, of a variety of ways of generating the SpearV that goes into the driver. So you can do it the way it was for OpenGL, or you can start experimenting with the newer and different ways as well.
And John, correct me if I'm wrong, but some of those can be sort of linked directly into an application, so you don't have to rely solely on offline support if you were going to go that route, I suppose.
Yeah, I mean, we shall call it off-driver support, but yeah, you could do it online by, using a tool, a side tool, real time. It just isn't part of the core drivers, Vulkan driver stack.
How much sense does it make to use Vulkan without the Lunar SDK?
I can take that question. So I'm assuming the question is develop a Vulkan application without the SDK. All the elements in the SDK are actually available, open source, free, from multiple repositories. If individuals don't want to use the SDK, they could go find all the pieces and build it and compile it together themselves. Bringing it together in one place and providing a forum where questions can be asked was more of a service to help the developers get started.
Is there any benefit to having command submission on multiple threads, or will a typical program still use the main thread to do submission?
Hey, this is Graham. I'll take that. So if you have multiple queues, I think it might make sense to submit work to each of the queues from different threads. The queues themselves, you would need to serialize on a single queue. So if you had multiple threads submitting to a single queue, you could do it if it's convenient in your app. If you just have multiple threads that want to submit, obviously the synchronization is your problem, but there's probably no real benefit to doing that at all.
So we could add, I mean, it's a design intent of Vulkan that submit is supposed to be super cheap. So, and the heavy lifting is supposed to be done at command buffer construction time. So the kind of expected model for a given render target is to say, yeah, multi-thread the command buffer construction like crazy, but then, if you marshal all of those and have a single thread submit them, that's not going to hurt you. It's not going to be the tall pole.
Yeah, I would also add that if an application is, remains single-threaded, you can still expect CPU performance improvements and the stuttering improvements and so on that Vulkan offers. So going multi-threaded is not a requirement to reap the benefits of Vulkan.
I have two questions about rendering. Can Vulkan be used for headless rendering, and is it ready for stereoscopic rendering?
So multi-view is on the agenda for future work, which would include stereoscopic as an important special case. Headless rendering, sure, Vulkan natively doesn't even have Windows system integration built into it. That's an extension. So definitely headless rendering now, multi-view in development.
Thomas, we're talking about how it's the integration with the Windows system is much cleaner with Vulkan than OpenGL.
Sure. Who would like to take that? I do think it is a better model, but
yeah, it's just that the there's two aspects to the WSI extension. Is that, as the questioner was asking, if you don't need to render anything, you don't have to concern yourself about getting a display surface in your context. It's much better partitioned, and if you do use the WSI extension, the swap buffer architecture there is nicely low level and explicit, just like the rest of Vulkan. So it's a cleaner and more flexible Windows system integration this time around. So
one person is asked, saying 3D graphics seems to be an emphasis. Can 2D graphics be done in Vulkan?
This is Graham. Well, Vulkan is a very low-level API. You can draw. If the GPU is capable of it, you can draw with it. At the moment, it exposes pretty much the set of primitives that core OpenGL does. So, if you're talking about drawing lines and screen-aligned quads and things like that, sure. If IHVs have support for real actual hardware that accelerates 2D better than you could do it with the 3D engine, then I'm sure those things will probably show up as extensions, and I expect them not too distant future.
What performance improvements might a well-tuned OpenGL application for games and simulation expect with a switch to Vulkan?
Let me try that one. So if your application is well tuned and is GPU bound at present, you'll perhaps notice some reduction in CPU power, and the CPU may be idle more often, but you're not going to get a graphics difference because the pipeline is the pipeline, and if it's maxed out now, it will be maxed out in Vulkan.
Yeah, I mean, I suppose the one thing that you might expect to see as sort of an extension of what Tom was saying, sorry, this is Jesse from ARM, is that because you'll get many of your CPU cycles back, you may have the opportunity to enhance your rendering using some offline sort of CPU techniques, and you may get more out of that if you choose to give back some of that. If you just are very happy that you're using less power and your CPU is idle more of the time, that's great. But you may choose to add some techniques back in outside the rendering pipeline, so that you can still get better results, but you're doing it in a combination of CPU and GPU work.
Will Vulkan support Khronos' GLTF?
I can answer that one. So GLTF is just a file format for efficient transmission of 3D assets across a network, typically into a web-based application, often using WebGL. So yes, there's no. If you have an application that's using WebGL or Vulkan, there's nothing too specific about GLTF that would mean you couldn't use it together.
Is Vulkan ready to be used for safety-critical applications?
I would say that I wouldn't call the current crop of drivers mature. I would say that's coming. The fact that it's a much more transparent API is a positive for safety-critical systems, but obviously, in a safety-critical environment, you're going to need to move slowly and do a lot of testing and closely with the platforms that you intend to target. Because I think, I mean, to be frank, we have a conformance test. It is not rock solid. It does not have 100% coverage. We are improving it as fast as we can. But right now, I would say it's time to be planning and developing, but not fielding.
And if the question is asking about ISO 26262 certification, I mean, as I mentioned briefly, there is quite a lot of activity inside Khronos right now about building safety certified versions of the various APIs. That's an ongoing discussion. We have OpenGL SC, which is a safety certifiable version of OpenGL ES. There is no current safety certified spec for Vulkan, though now the Vulkan 1.0 spec is out. I think that discussion will gain more momentum inside Khronos.
Can you talk about any interaction between EGL and Vulkan?
Well, so I guess what I'll say is, and I feel like I'm speaking out of ignorance, it was essentially the EGL team that developed the WSI extensions for Vulkan, and they're intended to play the role for Vulkan that EGL plays in the OpenGL ES world. I think I'm oversimplifying the case. I'm afraid I'm personally not very involved.
Yeah, no, I think you're correct. The WSI extensions are essentially the new generation EGL for Vulkan.
Are there any plans on Vulkan and OpenCL interoperability?
The OpenCL working group has started to discuss that. We don't have it yet, and we have interop with OpenGL and DirectX, so interop with Vulkan would make perfect sense. So yeah, watch this space. We don't have it today yet.
Is a shader debugging tool for Vulkan available?
I don't know if LunarG wants to take that, but there are people doing work in that space. Go ahead, Karan.
I know that there's. I don't know the answer to it. I was actually hoping John Kesenich might be able to shed some light.
Yeah, I know people are doing that. I can't remember the names right now. So if you look out in the web, I'm sure you'll see what's going on in that space.
Well, I was going to say the problems of it's of course the holy grail of symbolic debugging of shaders in high-level language is unsolved in OpenGL, and it's going to continue to be very difficult, perhaps even more difficult in the new world where the high-level language compiler is further decoupled from the driver. There are obviously debug features in the LunarG SDK and in the layers, but they are more at the level of well, similar to the debug functionality that you get with the debug extensions in OpenGL.
How close is Vulkan with AMD's Mantle API?
Hey, this is Graham. So the original proposal for Vulkan that we made quite some time ago now was basically a sort of cleaned up version of Mantle that we just dropped on the table and said, here guys, have this. And I think it got the conversation really going. But over an 18-month period, there has been a lot of contributions from a lot of the other members at Khronos. Some sort of small tweaks, some really kind of major features. Like the render path thing was never in Mantle, for example, and it's kind of a core part of Vulkan now. So, yeah, I mean, there's an obvious heritage there, and if you have experience with Mantle, I don't think you would have any trouble at all moving to Vulkan. Some of the API names are the same, and it's lived on there. But it is a significant update, and there are some fairly significant differences and enhancements and things we should have done better maybe in Mantle got into Vulkan. So I think overall it's probably a better API overall, and it's cross-vendor and cross-platform. So I think we've landed in a really good place.
If I could just comment as working group chair, the impact of AMD stepping forward and saying, here's a place to start was huge on the working group. I don't think we would be where we are without them. And I think we all take off our hats to them and their lawyers who were actually willing to make that happen.
Very much so. Well, we have time for just one more question. Does Vulkan offer anything to an application model that is limited to a single thread?
I think Jeff addressed that to some extent. You should not underestimate the impact of the fact that once your application is debugged, the driver has no native checking. The only validation it does is what it absolutely has to do to pack driver structure data structures. That's a big win. The other is that because it strongly encourages / requires you to build things ahead of time so that the driver doesn't have to make guesses about your intent at runtime, that also has a huge impact. It means, for example, the driver is doing much less dynamic resource tracking and checking. So the answer is yes, you will still get a significant improvement in performance unless you are, as I said, GPU limited already. Anybody else want to speak to that? Some of you desktop guys?
Yeah, I always be an advantage to have less of the hitching for, you know, in OpenGL something might happen deferred and it surprises you. So Vulkan improves on that. Sorry, Jay.
Yeah, and I think that's really important for like real world applications. You know, so much time in the OpenGL development cycle is spent on dealing with driver variation and with hitching and just, you know, quirks of individual drivers. And if Vulkan smooths over a lot of that, which we hope and expect it to, then in the long term, Vulkan can actually be a more productive API to develop on than OpenGL. So kind of for initially writing or porting an application, there is more code to write for Vulkan than for OpenGL. But in terms of like a big application, the overall effort could still be less for Vulkan.
Excellent. All right. Well, thank you, everybody, for participating, and our great tech experts for answering our questions, and of course to Neil and Karan for their presentations. And thanks, everybody, for joining our webinar. We're going to go ahead and close it out now. You'll get an email in a couple of hours with a URL where you can go to get a recording of the session. All right. Thank you so much, everybody. Bye-bye.